Hello, welcome. Today we are going to look at chemical kinetics, and this is tutorial question number 1. All right, question 1. So the table 12.4 shows initial rates from 3 experiments for the reaction this. All right, so we have experiments here. We have initial concentrations and initial concentration for these 2 reactants, and we also have the initial rates. So what are we going to find in this question? We are going to find different stuff, like we are going to find the rate law, the orders, and the overall order, and so far and so forth. All right. We are also going to find the rate constant. So come with me here and let's do what we're going to do. So step 1 is that we are going to write down the rate law, the rate what law, and follow me very much. So how do we write the rate law? Before we even go anywhere, how can our rate be written? So we can write our rate as K. Now we only have 2 reactants, so that would be concentration of NH4 plus. So we can the order. We don't know the order in which the reaction is going for this particular reactant, so we can call it order M. Then the next reactant is this. We also don't know the order, so we just leave it like that. So this is our rate law, but we need to find what M and N are. Those are the orders that we need to do at to find in order to come up with a complete rate law. So how exactly do we do that? So follow me. So we can get experiment 1 and experiment 2. Why? Because these 2 are equal, so that at the end of the day they are going to cancel. So from experiment 1, our rate is equal to the initial rate is 1, the 1.35 multiplied by 10 to the power negative 7. I'll be leaving these moles and whatever, I'll leave them, is equal to K. I'm going to put K there. And so the concentration of this friend of ours is just 0.100. Then to the power M. And the concentration of this one is here, which is 0.0050 to the power N. We keep it. We go to experiment 2. Our rate is, we have this one there, 2.70 multiplied by 10 to the power negative 7 is equal to K. We're still getting 0.100 to the power M and 0.010 to the power N. So these, they are going to cancel so that we can find N alone. Then do you know what we can do here? All right, so we can now find the ratio. All right, find the ratio. So we can say divide like this, rate 2 over rate 1. So what do we get? Rate 2 over rate 1. Why am I dividing? Because I'm dividing the smaller one into the bigger one, because I know that the smaller one can go into a bigger one by a larger number. So be strategic as we're doing this. All right, so what do we do now? We have 2.70 times 10 to the power negative 7 over 1.35 times 10 to the power negative 7 is equal to K and K. Of course, they will go away together, right? K and K will disappear, but we are going to write them. K, so 0.100 to the power M, then 0.010 to the power N over, then K here, then you have 0.100 to the power M, and we've got 0.0050 to the power N. So these two, they go, including the K. And once they go, what do we remain with? So we can now divide, get your calculators. All right, so we divide 2.7 times 10 to the power negative 7 divided by this. All right, so personally I'm getting 2. So here, this one goes there 2. Yeah, I'm getting 2.0 is equal to 0 into there. That just 2 as well. So 2.0 the power what? N, like that. You get the concept, right? So laws of indices, same bases, that means the power there is 1. So N is just equal to 1. So we found the 1. All right. What does this value tell us? All right. The value of the value of N is 1, but what does this tell us? Remember that N is raised to this power, this friend of ours there, right? It means this is just the order in which this reactant is moving. So that is of order 1. So we can conclude and say this is of order 1. Next, we find M. We do the same. We need to pick 2 experiments from here that can help us to do this. We need to target where we can cancel. So we can cancel this so that we can remain these 2 because we're looking for M. M is attached to there. So we go to experiment 2 and experiment 3. So I'll go straight now here. Since we know how to get them, I'll just go to the ratio. So the rate, so I can get rate 3 over rate 2. And I know that we have respective this and this, they are dividing. Then these they are going to cancel, and this one is dividing. All right, because of great. So 5.4 times 10 to the power negative 7 is dividing what? 2.70 times 10 to the power negative 7 equal to, yes. So now 0.2 is dividing 0.1. But we've got k there. I have 0. What? 200 the power m multiplied by 0. What do we have here? 0.01. 0.01 to the power n over k 0.01 m, again 0.01 n. Again, these they cancel, that they cancel, so we end up remaining with this is just the double of 5.4, so we get 2 is equal to, so 0.1 can go into 0.2 twice again, that is 2 to the power m. Even here m is what? 1. M is 1. So what are we saying about this friend of ours there? What are we saying? This also is of order 1. Now that we found the value of m and d, n, can you write the complete rate? So therefore the rate is equal to k n h4 plus. We are not going to put m here because now it is what? 1. So just leave it like that. Then we have NO like that. Even here we can't put 1. So this is the rate law. Can you help to do this? Now we need to find k. So what is k? So with the rate constant now. Let's find the rate constant. The k. How do we find the rate constant? So to find the rate constant, we can get any 2 experiments and divide them. All right. It will be very easy, like it's fine. All right, let me show you. So we know our rate is like this. So if I get from experiment 1, let me do this. If I get from experiment 1 there, what am I having now? All right, okay, I've seen it. So the rate there is 1.35 from experiment 1 times 10 to the power negative 7, which is equal to k. We have 0.100 and we have 0.0050, if I'm not mistaken. Yes, we're just getting these two. Replacing them here, we're just replacing them here. So from experiment 1, I've just gotten whatever is here. I can't put anything there because the values there are just 1. So if I multiply these two, so 1.35 times 10 to the power negative 7, multiplying these, all right? So what we can do is this. Okay, we can divide both sides by 0 0.100, 0.0050, even here 0.005 multiplied by 0.100. So gone, we have our k there. So the product of these two, so this is so we have 0.005 multiplied by 0.1. So we are getting 1.35 times 10 negative 7 over 0.0005. So we divide 1.35, okay, by 0.0005. So this will give me 2.7 times 10 to the power negative 4. But it needs to have units. What units are you using for this? Fine. At the beginning here, we have more per liter dot what in second. So what do you think will be our unit? All right, so this will be liter. It's like they're going to reciprocate now, okay? So liter more per second. They're going to reciprocate. Just like that, you found the value of k. Now, what about what now? Next is the overall order. What is the overall order of a reaction? So the overall order of a reaction is equal to m plus n. So 1 plus 1, so 2. So it means the entire reaction is of order what? Of order 2. Hence, the reaction is of order 2. But it is of order 1 with respect to this friend of ours and this friend of ours. Remember, we found that the order for this one was 1 and the order for this one was 1. So with respect to these two, it is 1, 1. But the entire, it is 2. So thank you so much for joining me, and I hope that you enjoyed this video. Please subscribe and, well, invite others, all right?